Hello everyone and welcome to this video. Gradient descent is a key technique in machine learning and deep learning used to find the minimum of a function. It helps in optimizing model parameters by moving iteratively towards the steepest descent. Let's explore some key concepts. Partial derivatives help us compute the gradient, which shows the direction of the steepest increase. The learning rate is a crucial hyperparameter that controls the step size towards the minimum. A small learning rate means slow convergence, while a large one might overshoot the target. For more in-depth information, you can refer to the linked paper. Let me show you how you can implement the gradient descent algorithm using Python. We start by importing NumPy, then we define a function called gradient descent. This function takes a gradient function, an initial theta, a learning rate, a tolerance, and a maximum number of iterations as parameters. We initialize theta with the initial value and iterate up to the maximum number of iterations. In each iteration, we calculate the gradient using the provided gradient function. We then update theta by subtracting the product of the learning rate and the gradient. If the change in theta is smaller than the tolerance, we break out of the loop. Finally, we return the optimized theta. This function is a simple yet powerful way to perform optimization. Now, let's see an example of how to use the gradient descent function to minimize a simple function. F of x equals x squared. We define a function called gradient of f that returns the gradient of f, which is 2 times theta. We set the initial theta to 10 and call the gradient descent function with a learning rate of 0.1. The result is the optimized theta, which should be close to 0, the minimum of the function. This example demonstrates how gradient descent can be used to find the minimum of a function efficiently. Let's dive into some further insights about the gradient descent algorithm. It works by updating parameters in the direction of the negative gradient, leading us towards the function's minimum. The learning rate is crucial for determining how fast and stable the convergence is. In terms of computational complexity, the time complexity is proportional to the number of iterations and parameters, while the space complexity depends on the number of parameters. Thank you so much for watching this video. Don't forget to subscribe my channel and see you next time.